step 4, and then eventually we'll put them all together. Today, this section, we're talking about period, the concept of period. Now, period means how far it goes before the function repeats. Well, if you recognize, the period in all of our graphs so far has been 2 pi, because it takes from 0 to 2 pi to get a full cycle of the graph in before it starts repeating and doing exactly the same thing it did before. So both for sine and for cosine, we've had a period, that wasn't right, of 2 pi before. So cosine starts at the top, baseline, bottom, baseline, back to the top. That took 2 pi. That's why the period is 2 pi. Same thing here. Starts at the top, baseline, bottom, baseline, top. Took 2 pi to do that. That is a period of 2 pi. So when you look and see what a typical period looks like, one period of sine gives you the general shape. Baseline top, baseline bottom, back to baseline. One period of cosine, since it starts at the top, baseline, bottom, baseline, back to top. That's one period. As I mentioned, every one of our periods so far has been 2 pi. But that's because there hasn't been a coefficient in front of x. All of the coefficients in front of x have been 1, which is the reason that our period has never been anything different than 2 pi. But if there is a coefficient in front of x, such as right here, we have to take and divide our normal period, 2 pi, by the coefficient of x, which is 2. So, right here, to find our new period, we take 2 pi, our original period, and divide it by the coefficient of x, which was 2. Well, 2 pi divided by 2 is just pi. Pi is the period of our new graph. So, down here, when we're graphing, y equals the sine of 2x, we have a new period of pi. So there's no phase shift, no vertical shift, no amplitude other than 1. So we still start at the same place, right here, 0, 0. This is a sine graph. We start at 0, 0. But what it means is we have to be finished with our graph, finished with a full period of our graph by the time we get to here, pi. So that means everything has to happen faster. You know what happens with sine, right? The sine starts at the baseline, then it goes up to the top of the amplitude. Then halfway between the 2 points, halfway between the period, it's back to the baseline. Then in the third quarter, it ends up below at the negative amplitude. And finally, at pi, it ends up finishing a full cycle. So look, we've finished the full shape of the sine graph this time before we got to pi. So because there was a 2 in front, it ended up making our cycle smaller. So the same thing would happen again. It would end up top, baseline, bottom, back to baseline. It would continue doing that. We can get more cycles in a shorter amount of time when we mess with the period. Or it could sometimes take longer to get through a full period. So let's go ahead and stop and write our PowerPoints now before we forget. But you might be thinking, well, wait a minute. I don't know where this point is right here. I haven't dealt with that x coordinate before. Well, if you think about it, this was at 0, 0 right here. This point right here was at pi over 2, 0. Well, this point at the top has to, obviously it's going to have a y coordinate of 1, but we got to think about its x coordinate. Its x coordinate is going to be exactly halfway between 0 and pi over 2. Well, if you can think about it, this is 0, this is like a half. What's halfway between 0 and 1/2? 1/4. 1/4. So this is pi over 4. That's our power point there. So we got that one. We got this one. Now we got to figure out where's the x on this one. Well, if you can think about it, this is like, again, 1/2 pi. This is like a whole pi right here, whole pi. So what would be halfway between 1/2 pi and 1 whole pi? 3/4 pi. The y there is at -1, and the last point we have is pi 0, back to the baseline. These are our power points for this graph that has had a change in period. Let's check out and see what happens when the cosine graph changes period. Not really much different, but this time actually the period is going to get wider instead of skinnier. Because again, we have a coefficient in front of x, which means it is going to change our period. Well, this one's a tougher one. Remember what we did last time? The new period equals 2 pi over the coefficient of x, which is the 1/2 this time. Well, this means we're going to have to do some fraction division. 2 pi divided by 1/2 is the same as saying 2 pi times 2 over 1. We flip the second fraction. So our new period is 4 pi. That's our new period. So let's look what happens, what that means. That means our cosine graph starts at the normal place because there hasn't been any phase shift, there hasn't been any vertical shift, there hasn't been any amplitude change. So it still starts at the same place. But before it gets through a full cycle, it takes all the way until I get to 4 pi before I finish a full cycle. Right? Cosine starts at the top and ends at the top. Now halfway between, where is cosine? Between the beginning and the end, where is cosine? Halfway between, it's at the bottom of the amplitude. Okay? And then you remember cosine, at the quarter points, it's on the baseline. So this function, this time since I had the 1/2 out in front, it actually is a lot wider. It takes a lot longer before it actually gets through the full cycle. This time it took a full 4 pi to get through the cycle. So let's get our power points listed real quick. We have 0, 1. We have pi baseline, which is 0. We have 2 pi -1. We have 3 pi baseline, which is 0. And we have 4 pi 1. Those are our power points for the graph this time. So period is going to mess with how wide or how skinny our graph is. We have to find it by taking 2 pi and dividing it by the number in front of x, the coefficient of x. Give these next ones a shot.